Good afternoon. Is everybody awake? Awesome. All right, my name is Lige. I'm the Chief Technology Officer for Ivy Tech Community College. So if this doesn't sound like the room you want to be in, now's your time. So show of hands, who's heard of Ivy Tech Community College? Oh, wow, really? Okay, so we're in Indiana. Who's heard of Indiana? More hands went up on that one. Oops. So I'll start with telling you a little bit about Ivy Tech to sort of set the context. So Ivy Tech is Indiana's community college, if you will. We've got, well, I won't read this to you. We have a lot of stuff. So about 170,000 students, and if you're in higher ed, this course section number will make a little bit of sense to you. 60,000 course sections every single year. Fair amount of online. If you're in IT, the next number might scare you a little bit. We have about 1,200 software applications that we support across the enterprise. On a given day, we have about 100,000 devices on our network. More than half of those are student devices, about 45,000 or so, depends on the day. Excuse me. Our user base, which would include students, faculty, and staff, is around 727,207 as of yesterday. So it's a little out of date. The important part is we generate an awful lot of data. So we generate about 100 million rows of data. I don't know if that makes us big data. I don't know, it depends on the definition. It's a lot of data, so we'll go with that. So we generate an awful lot of data, and the vast majority of that is related to our business, obviously, but related to students specifically. And so that's what we're going to talk about a little bit about today. So there was a business problem. This came up about 4 years ago. The president of our college had said, you know, our students are not persisting and thus completing as much as they would like. So does somebody that's not in higher ed know what persisting means? Say I got you on that one. So persisting is really going from fall to spring, or from spring to summer, or perhaps spring to the next fall. It's going from one term to the next is persisting. So as a community college, we're not alone with this problem, but this was something that we were going to try to tackle. So in the IT department, we decided to see what can we do about that. I mean, we're not educators, luckily. By a show of hands, who's in IT in here? Right, so a lot of your folks you wouldn't want to let out of the server room either, right? So we have the same kind of issue, but there are other ways we can help, aside from having those folks talk to students. So some of the tools that were available to us, obviously you guys have heard of this one, I hope. Okay, nobody raised their hand on that. So AWS is a big tool for us. As a community college, we are very cost conscious, and we are not big fans of buying big iron, big monster sands that we won't get the full value of until it's time to buy another one. So pay as you go is a model that we like because it allows us to realize the maximum amount of that investment immediately, if that makes sense. Another tool at our disposal was something we call Newt. Newt is a custom-built data warehouse that my team put together. And there's a whole story behind that, and we can talk about that later if someone would like. But it stands for the new thing. And so we got tired of writing thing, and so we just chopped it off and paid an intern, and so now we have a logo. So we call it Newt, and that's another tool that's at our disposal. We'll talk about that in more detail. And then, of course, open source software. Being a community college and being in higher ed in general, we're big fans of open source. It allows us to do a lot of good things without spending great deals of money. And so that's really the three tools that we're going to talk about today. And if I talk too fast, somebody let me know. I have a habit of that. So one of the things that we sat down and talked about was, you know, what if we could tell automatically that the student is in trouble? And so there's lots of ways to do that. If you're in higher ed, there's LMSs that'll do some of that. Sometimes your SIS will do that. There's a lot of tools that vendors will sell you, I'm sure they're down the hall here, that claim to do that. But I think that the way that we do it's a bit different. So one of the things is, well, how early could we tell? What would we do about it if we could tell, which is also an important one? How accurate would it be? And then, of course, where would we start? So we really started with a fundamental question, and that is, what makes a good student? So I'm sure everybody in here has got an opinion on what makes a good student, right? Somebody? Nobody? Okay. So what we did, I had the same response. What we did was we reached out to a lot of our faculty and staff, and we asked this question, hey, what makes a good student to you? And these are actual responses. I didn't doctor these up. So, you know, a good support system at home, somebody that does their homework. From the finance folks, somebody that pays their bill is a good student. Someone that attends class, somebody that asks for help when they need it, someone that's very collaborative, like they like to work in teams. The engaged in class was another common one. Someone that asks questions, and then someone that doesn't ask questions. Those are actually two responses. So they're on here. Someone that has commitment, they have good time management skills, and they're driven towards a goal, they have a plan. And of course, somebody that makes good grades, right? That's a good student. So we really took one of those and we tried to drill into it a bit. So what does this mean? What does engaged in class mean? So it means a lot of things, right, depending on who you ask. It means someone pays attention, or they participate, they read their assignments, they do their lab work, they do their homework, which is one that my kids love. They raise their hand in class, or someone that enjoys their material. So these are the responses that we got from our folks when we tried to dive in on what do you mean engaged? What does engaged mean? So then we took those responses and we tried to figure out how could we represent that in data. So take participates in class. So one thing could be you log into your LMS, or that you emailed somebody about something, or that you go to labs in class and activities, or that you're using a discussion board that the class may use for some reason. You don't get flagged by an advisor or faculty as being a problem child, or a problem student, I should say. Someone that uses the chat system to chat with their peers, or someone that tweets about the class. So those could be ways that you're a good student. And another important point that we learned is that the inverse is also helpful. I call those holes in data. Just because you don't do something doesn't necessarily mean anything bad, but it could mean something good and vice versa. So the inverse is something really important to keep in mind, and this is not necessarily intuitive. But basically this list is the inverse of those other things. So getting flagged by an advisor would be the inverse of getting flagged by the advisor. So important point, and don't lose sight of that one. And then more specifically, if we look at how do we represent in data with data that we can actually get our hands on. So, LMS login actions. If you're in higher ed, you're familiar with an LMS, you can actually get login data. When did Johnny log in? When did he log out? If he logged out, things like that. Metadata from the email system, who was emailed. Not necessarily the text of the emails, because that's a line of creepy big brother that you don't necessarily want to cross, but metadata about maybe the subject, or maybe the time, who the recipient was, stuff like that. Data from other systems that we have. You recall earlier I mentioned we have 1,200 systems. That's a lot. And so it turns out we got a whole lot of data about a lot of different things. Just general log information from our portal is a big one. We channel our students through certain paths, if you will, to get to certain systems, and we can figure that out right from the portal logs. Our advisory system keeps data. Some of our chat systems keep metadata about what's going on. So there's lots of ways, and then of course Twitter. If you guys have gotten the Twitter, there's a wealth of data in Twitter, and our students love to tweet. I don't know about yours, but ours are big on that. So, sort of to back up a little bit, this is sort of a high-level diagram on where the data comes from us. So if you look at the top, these are what I call the cloud data sources, and there are about 243 of those for us. I didn't put them all on here, but. And then, of course, we have Oracle, where, if you're familiar with higher ed, we're a Banner shop. And so Banner is our ERP, which rides on an Oracle database. So this is how we get all that data out. There's a variety. We can go into more detail if someone has a technical question. There's a variety of ways that we do that. But the big thing here in the middle is Airflow. If anybody's familiar with Airflow, we use that as a coordination tool. It's open source. So we use that as a coordination tool to help us get this data in a timely manner, in the most efficient manner. And then we also use Slack. Is anybody familiar with Slack? Somebody seen a commercial maybe? So we use Slack a lot, and we also have built Slack bots to control everything that goes on with our data warehouse, and it's kind of an easy, slick, and very communicative way to do that because other people who are on that channel can see what you're doing. So it's a pretty cool little way to do it. So Airflow coordinates all that stuff, and then we do a couple things with it. So we push it into S3. You guys are familiar with S3, right? And then that goes into Redshift. Redshift is the back end for the Newt system that I drew, or that I showed you a little bit earlier. Then we also peel that data off and we go to some open source software, which is represented here by TensorFlow and scikit-learn, for doing some machine learning and some more data stuff we'll talk about here in a second. But we do a lot of machine learning to look at that data, analyze behavior patterns and things like that. All that eventually goes over to Redshift as well. So in our data, not only do we have what the system said you did, then we also have some derived things that we've learned about you based on the data analysis that we feed back into that same system. And then as a fun side note, we also throw everything in Glacier, mainly because it's cheap, but it allows us a way to go back and see what things look like before it got ingested into the system. So that's our high-level diagram. I see a couple people taking pictures, so I'll leave it for a second. Okay. So this, if you're familiar with Airflow, or if you're not familiar with Airflow, this is a directed acyclical graph, which gets all nerdy and mathy on you. But essentially, this hot mess you see in here is the data flow from those 200 and some odd systems that make it into our Newt system at the end of the day. So the good news is we are working on a new version that's a lot simpler, because this hurts everybody that looks at it. But there's a whole lot of orchestration that goes on that brings that data in. And I won't bore you with all the gory details, but certainly feel free to ask if you're more interested in it. So we bring all that data together. And we want to analyze it, and we want to look at student behavior. We want to identify, as you might recall, who's a good student and who's a bad student, and we want to know that as quickly as we can. And by bad student, I don't mean a student that's a bad person, because I get that question. What I mean is a student that gets an A, B, or a C, for us, is good, and a student that gets a D or an F, or anything worse, right? They drop out or they don't show up or whatever, that's a bad student. The Ds are included for financial aid purposes. We have a large percentage of our students that are on financial aid, being a community college, and that is detrimental to them, and so we classify D as bad. So no judgment there, that's just the way we do it. So we categorize the data into really two different buckets, and what I call natural features are things that are easily derived from the system. So things that can be summed, averaged, pulled out, that's easy to get. This is the easy stuff. So an example might be who's logged into the LMS in the last 24 hours, the last 7 days, the last month. That's stuff that junior level people can get at. We can get that data coughly, and we can get those features identified. The synthetic features are, and that's spelled wrong, by the way, so keep a note of that. So couldn't figure out what that word was. Synthetic features are the ones that we look at and that are basically designed features. So we take these, and I've got some examples. How hard are you working is one that's, it's not a number that you can query from the database, right? And if it is, it's probably not one you should trust. But we can look at various different indicators, and collectively they could measure how hard you work. And those we call synthetic features. Probably not the proper terms, but these are the ones that we use. And we'll give you some examples. What we do with all that stuff is we take it and we throw it in what we call the blender, and that's the machine learning tools that we've developed. We use TensorFlow for some pieces and scikit-learn, if you guys are familiar with scikit-learn, for some other pieces. Bring all that data together, and there's a lot of it, and we can get into detail on it here in a second. It's a cool animation. And what we get out of that is a model for what a good student's behaviors are. So a couple important tidbits, and I may have this a little bit later on the slide. Well, let me show you this first. When we do this, we're 83% accurate. So what we do is we take all these behavior metrics or features, and we look at them, and we bounce that up against all the other students that have been there before you. We let the machine do the learning. And when we did this in this past fall, in week 2 of a 16-week term, so day 10 of class, we were 83% accurate, and we predicted how you were going to do 14 weeks later. So it turns out there's a lot of value that can be derived very, very quickly if you get the right data involved. So what's it good for, right? So one of the things we do is we call it predicting student success. We do not look at, and we'll talk a little bit about this too, but we do not look at demographic data. The fact that you're a bald 40-year-old white guy in Indiana doesn't matter. We don't even look at that. And the reason is because we can't change that. It's hard, especially if you're bald. It's hard to fix some of those things. So what we do is we look at behaviors, things that we can influence as an institution. We don't necessarily care. We do care, but there's not a lot we can do about demographic stuff, but there is something we can do about behavioral attributes. So we really focus on the behaviors quite a bit. And we can very quickly, as I mentioned, within 10 days, we have a high confidence of how you're going to do in that class 14 weeks later. And, that's just what I just said. So another thing that we don't do, you'll hear me say that more than the things that we do, but one thing we don't do is build a model. We don't have some big statistics model that we worked on for eons that we try to push every student into. We don't approach it that way at all. We let the data define the models, and we let the data define the student cohorts. We don't lump students in hopefully, bald white guy cohorts, because that may not be accurate, but the data will tell us what those cohorts really are, not what we think they are. So we don't build models. What we have is a system, and I showed you some pictures of that earlier, a system that takes that data and then builds a model for us. And it does it very, very quickly, and we do it every single day. We look at the data that happened, everything that happened in the last 24 hours, regenerate all that stuff using the machine learning tools, and we build a model on what we think you're going to do the next day. And that's essentially how it works. So I'll give you an example, and this is the one that I happen to know numbers on off the top of my head. In fall of 2016, we identified out of the 100 and some odd thousand students that we had about 16,000 that were at risk of being a bad student, and we called them. We actually had a college-wide initiative where we took people that were volunteered and some were voluntold, but we had folks that got together and we just called every single one of those students. And sometimes we had to call them twice, and sometimes 3 times, and sometimes we didn't get them, but usually we did. But we called every single one of them, we chatted with them. What we didn't say was, hey, Bob, we hear you're gonna flunk that math class. because that wouldn't be helpful. But what we would say, and this was all scripted, is Bob, how's it going at Ivy Tech, and how is that math class going? And it was amazing, some of the things that we learned from that. Let me see if it's on there. Yeah. So give you the results, and I'll tell you one anecdote from that I think was pretty cool. So by the end of the fall term, we went back and we did some analysis, and we ended up with 3,100 more students pass their courses than we expected to pass in previous terms, and we have data going back almost 50 years. So not saying that this initiative was the only thing that influenced it, right? There are other things going on, but that was the largest increase in passing grades the college had recorded in over 50 years. So we're pretty excited about that. So another couple fun tidbits about the phone calls. So those folks that were volunteered and voluntold to call, we collected data on those phone calls. Every caller kept a log. We had a web form. They did categorization, how was the student, were they receptive, not receptive, but then also give us a paragraph of what happened. And then we went back and analyzed that because we have an analyzation problem, right? We're OCD. So we analyzed all of this stuff to see, is there anything else that we could learn? And the stuff that we learned from those text boxes was far more insightful, in my opinion, than anything else that we learned. We learned that our bookstores weren't really doing what we thought they were doing, that maybe we needed to adjust some contracts. We ended up with, I believe it was 7 students who had had their electricity shut off. Out of the 100 and some thousand, 7 is not surprising, right? But if your electricity gets shut off, your first or second or probably 10th phone call is not to your college, right? It's probably to somebody else. But it turns out we do have programs at our institution that can help with students in need. We have a lot of students that have these issues. But we didn't know that. What happened was their power got shut off. It affected the behaviors that manifested itself in our data that we caught. We called and said, hey, how's that math and English class? We're wondering how it's going. Well, I hate to say this, but this is what happened to me. And we were able to help those students because we actually knew about it because they showed up in the list. So that was kind of one of my favorites because I thought that was very impactful. It's not a huge number, but it's pretty neat. So from the Redshift side, since we're at an Amazon conference, there's a few things that we've learned to save money because, again, we're a community college. So with us, traditionally, especially with on-prem solutions, we would have a dev, test, and production environment. That sounds familiar to some people, I hope. Okay. So we have those 3 environments. With us, in our Redshift, we keep it all in one cluster and we manage those environments, if you will, with permissions and execution queues. It allows us to get more bang for our buck. We get a lot better performance when we're not using dev and test, and it's more dynamic that way. So we can talk about that if anybody has questions. We definitely do a lot of analyzing and vacuuming of tables. If we don't do this, we end up with trouble. Our largest table in Redshift is over 1 trillion rows now, and we've got a lot of data there. So us keeping those tables performant is a big deal for us. Another thing that we've learned a lot is distribution and sort key tuning is a big deal, especially as your tables start to hit hundreds of billions of rows. It's kind of a technical nuance, but if you haven't gotten to that point, something you definitely want to keep an eye on. And then, of course, tweaking those settings, like anything else, could have adverse effects on other queries. That same database is used for the predictive analysis and machine learning, as well as end users, faculty, and staff logging in and checking their enrollment numbers and finance running whatever they do. So all of that comes from the one system, so we have to be careful how we tweak those settings because it's kind of a big deal. Now, the cost part, this is one of my favorite parts. We've got approximately 30 terabytes. This is a bit dated. It's a bit bigger than that now. But we 30 or so terabytes in there. When we had started this Newt project and we decided we want to do all this stuff, we went out to the vendor community. You guys familiar with RFPs, that 3-letter acronym? So we had done the same thing, right? We'd went out and done RFPs and gotten quotes, many quotes in the 7 figures, and I think one of them hit 8 figures to begin helping us. And just do the math, right? You're spending hundreds of thousands of dollars a month and this, that, and the other. So obviously we don't spend that much. But what we spend on software costs today is $3,200 a month. So we went from vendor proposed solutions, which were well in the 6 figures, to, which I think is pretty reasonable at least, $3,200 a month for everything that we've got. Well, and there you go. So it's about 95% cheaper than anything else we could find. So we're kind of happy about that. We also use that system for a variety of other things. We've done a lot of predictive analysis on a lot of things that we didn't intend it to do. It sort of turned into, when you have a really great tool, it's amazing where you can use it. We've used it in a variety of other places, and I could talk for 3 hours on some of that stuff. But one of them was this. We've got, in our system, we probably have close to 4 million students. which is approximately half the population of Indiana, if you've ever been to Indiana. So a lot of people have been through Ivy Tech in some form or fashion. When you consider that folks come from other institutions, transfer credits, they don't transfer credits, financial aid rules affect how the transfers work, it's kind of a mess. If you're not in higher ed, trust me, it's kind of a mess. But there's a lot of data that gets involved in it. We would have students that would start out at another institution, maybe studying engineering, come to Ivy Tech and do engineering technology, take a bunch of math classes, and then end up dropping out for some other reason, and we would never hear from them again. It turns out that maybe they earned a certificate or maybe even a degree in accounting because of the heavy math focus they had, but they didn't realize that, their advisor didn't know it. We have 700 or 800 programs at Ivy Tech, I don't remember the exact number, and 4 million students. There's a lot of data to churn through. So we use this system to go through that stuff and proactively identify students that may be very close to a credential of some sort or a degree even, and we identify them proactively. And so we started this in the fall, so I guess it would have been, no, about a year ago. We started this about a year ago, running this analysis to identify students that maybe had credentials they didn't know about. And the first run, we ended up with well over 2,000 credentials that students had earned. So we called those students right around Christmas time and said, hi, how you doing? Did you realize you have this diploma or certificate or credential, or did you know you had this? Would you like it? There's a pretty high percentage of the folks that did want it, believe it or not. And so that was a Christmas present. But now we're doing that on a daily basis. About every 4 weeks, we run through this data with approximately 4 million students, well into the 100 millions of rows of data across 800 and some programs, across 19 campuses. And we look for every possible combination to try to identify students that are close or have earned something that they may not be declared for. And unfortunately in higher ed, that is a challenge, and I'm sure there's other higher ed folks that are hopefully nodding their head yes, or if not, we need to talk. But it was certainly a challenge for us. But now we can do that in 4 days. It started off, it took us about 6 months to do it, and we've gotten it down to 4 days with the system that we have now, which is just a bonus for everybody. The bonus for Ivy Tech, aside from just doing what we're supposed to do, right, help students, is that we're also performance funded from the state of Indiana. So, and I don't remember the exact number, it's approximately $2,000 per credential for our students, so you can do the math. It's a big number. I like to tell the finance folks that this project has paid for itself. They don't always agree, but I have numbers on my side. So at a very high level, that's some of the stuff that we've been working on, and I don't have any other slides. But if anyone has any questions or wants to dive into any detail, I'm happy to ramble on for hours. Yes? We did. So the question was, if we don't build models, we had to, we have some tools, how did we start? And to be honest, we knew we needed a better data system. Ultimately, that's how we started. The system that we had, and I didn't go into details on the horrible systems that we had, but they're pretty bad. A lot of our 1,200 applications, let's say 50 of them were related to day-to-day operational things. So in other words, we wanted data from these 50 systems and dashboards. So what we had were 50 logins, hopefully not 50 passwords, but probably. And then our business and our academic folks had to remember how to run reports from 50 different systems. That's not good, and they didn't remember, neither did we, and it was not nirvana. So what we built was something that could aggregate that data together and get it on one pane of glass. That's actually what we started with, and that was the goal. And then it was we very quickly learned, wait a minute, so we've got all that together, which is a feat, apparently. And it was like, what else could we do with it? And then that's when we started digging into it. We actually started with a tool called Mathematica. Is anybody familiar with Mathematica? I'm kind of a math nerd, so I really like that. So I actually started with Mathematica and quickly ran into problems because of the volume of data. And so at that time, there were not any machine learning tools that were cloud enabled. So Amazon has one now. They did not when we started this 4 years ago. So that's when we started doing other things and playing around with Scikit and building it. But it came out of, well, we have this really cool tool. What we can do with it? And so we actually have ran into situations where we can proactively predict financial aid fraud. I can tell before you ever sign up for a class with a high degree of accuracy whether you're perpetrating fraud. There's all kinds of things that we can look at because the tool can do it. So it's not a great answer, but that's how we kind of backed into it. We didn't start with that in mind. And most of the good things that we found were after the fact, to be honest. We just needed a better reporting tool. We ended up with a very fast reporting tool with some very aggressive requirements. We hit the requirements and then just tried to figure out what else we could do with it. Any other questions about anything? Yes.
When you did your reach out campaign for your turnaround story, you mentioned like the 7 students without power, things like that.
Mm-hmm.
But like what depth of intervention was necessary to get that turnaround story?
So the question was, with the 3,100 students, how much did we have to do? To be honest, all we did was that one phone call. That was the statewide push. There were probably pockets of folks that did additional things, but where we started was let's just do the phone call and see what happens. And that was really what we started with. Now, since then, we have started to do more. And this coming spring, we have an expanded list of things we're doing, more consistent interventions, if you will. And so we're transitioning it from what we called project early success to project student success. We're wanting to make that part of the day-to-day operations, not an initiative that happens on week 3 with 847 callers. So we're really, the first 3 terms that we did it was more, that's what we did, but now we're trying to take it to the next level, and what else can we do with it? We have a lot of crazy ideas. Some of them will work, some of them won't. But I think we have a good baseline to go from. Yes? Yeah, so the question was around alerts. What else can we do? I know my answer. I'm not sure I remember the entire question. So, and that's really where the first 3 terms we just did the phone calls, and I can tell you a funny story about that too, but the phone calls that we did, and that's where the project student success that we're going to start in the spring is taking over from that. We're really trying to blow that out and do more with it. So we've had a lot of conversations about how to push this out to the students, right? If we know and we're pretty sure that they're in trouble, why don't we just tell them directly? And that's something that we're working through now. So it is advisors that do a lot of the outreach, but it's not just advisors. It's believe it or not, we've even had IT people calling students after they went through the training and the script, because we had more students to call than we had people to call them. So it has been advisors, but also been a lot of other people too, to do that outreach. And that's really where the work in progress is. We started with one very specific action, and then we realized, it did kind of work. What else could we do with it? And that's still in the works. So I don't really have a good answer to your question other than we have a lot of ideas, and we're going to do more and more and more with that, and hopefully get the numbers to be higher. Yes? Oh, we got a microphone now.
Thank you. So my question is around the certificate and degree completion that you're tracking. Mm-hmm. You said every 4 weeks. So do you have a homegrown system? Are you using Banner? I'm just curious, do you have all the classes pre-populated, and do you run a degree audit in order to be able to get those? And do you have students opt out of it? Or that seems very inefficient just to call everyone to see, do you want this degree, rather than granting it to them and have them opt out.
So the ones that, what we've done historically, and I'm not a student affairs person, not a registrar, I can just tell you what I've experienced with it, is we're a banner school. We're actually the largest banner school in the world, so the numbers probably will tell you that too. And we do have a degree audit system. It's UAchieve, I think, is the one that we're using. Neither of those tools scale well. If you're familiar with that, you know what I'm talking about there. So we had to work with the vendors as best we could on the degree audit side to get that system to get faster. And they did. They responded very well to our hard conversations. So it's much better now. So the audits are running almost continuously. Every 4 weeks, we're doing the complete audits just to see what's changed. Because we do have students come for 8-week courses. There are some 12-week courses. There are a handful of 4. So things are changing very, very quickly. And we really want to get back to the student as soon as they've earned it. We want to tell them. We don't want to tell them 9 months later. We want to tell them the next day, ideally, right? That you've earned this. The folks that we're calling today are the ones that are showing up on the list have earned something. Now, I know we've had some conversations with the registrars about how they want to adopt that as a more of a standard business practice and how they want to do that. But today, at least, I know they're calling them. There's probably room for improvement there, but that's really not my area. I give them the data, and then they figure out the most efficient thing to do with it. Not a great answer, but that's the answer.
Thanks. Dylan, I had a question about the learning curve or the actual ownership of faculty and the advisors. In California, we have counselors. So what was that experience like in terms of using data to help impact practice and also change behavior?
Man, you just jump right to the hardest question, don't you? So this is Elijah's opinion. This is on video. So this is my opinion. It took some time. So we developed this whole thing over 4 years ago now, and it took us a couple years to use it. And so we had years worth of, here's the list, I'm pretty sure they're gonna fail, and then 16 weeks later, or 14 weeks later, yeah, they all failed. It took a lot of that. It really was last August, we got a new president, and she's an industrial engineer, Dr. Elsperman, and she realized what we had, and I'm paraphrasing a bit, but well, we're gonna use this one way or another. And she said, you got 3 weeks, figure out what you're gonna do with it. And that's where the phone calls came from. And so we had a very short period of time to do something with it. And I think after those, the first couple of terms, the proof was there, but it really did take some, I don't know, nice politically correct way to say it, it took some drive from the top to get those folks to get on board. There was a lot of pushback, to be honest. There were folks that were interested in it, folks that really wanted to see it, and folks that said, and I'm kind of quoting, I don't need a machine to tell me who's doing well. So what are I'll give you one more pile on for that, since it's the favorite question. What are the 2 most impactful features you can think of when predicting whether a student's gonna do well in the course? What do you think? Okay, so attendance might be one, and of course I'm twisting your answer a bit. Attendance and grades, right? That's the 2 biggest indicators. We do not look at either one of those. Attendance and grades are not factors, features. We don't even look at it, we ignore them all. And the predictions that we do are purely based on behaviors, not necessarily the outcomes or those little intermediary outcomes. To be honest, when we include them, we get worse results. And so that's one of the reasons we ignored them, because they didn't help. But when we step back, and there's some reasons for that, that we could talk about offline. But yeah, we don't look at the 2 most common things we don't even look at. So there's one, well, several back there.
So you said that you don't use demographic features because you can't change them.
Correct.
I guess that gets at, what is the goal of these predictions? Is it to make the most accurate predictions and most accurately identify and reach out to those students who are at risk of failing or not persisting? Or is it to suggest these interventions? Because if this demographic data can help you predict better, is it worth using?
So there's a couple points to that. One of the things that demographic data does, and we did start using it because it's the natural thing to use, what we found was a lot of cases where your demographics were the reason you were on the list, right? So if you're familiar with machine learning, it'll give you rankings of feature impact and whatnot. We would end up with, the bald white guy thing as being the number 1, the bald and white, the number 2 reason you're on the list. And that's hard to make a phone call on. So it wasn't actionable data at that point. The reason we took it out is because it wasn't actionable anyway. I think there's a lot of value in it. It's just not for our purpose. What our purpose is who can we identify that we have a high confidence is not going to do well, and how can we help them? So the identification is where my group comes in. The what do we do about it is where the student affairs and the advisors and other folks get involved. And we do work very well together to try to help with that. So there is a lot of value in that data. For this specific project, I don't think there's as much value as you would think on the surface. The other thing to consider is what we're doing is not punitive, right? You're on the list. The worst thing that happens to you is you get a phone call. The worst thing that happens then is you don't answer the phone, and that's it. There's nothing punitive that happens. And if we happen to call a student that's a 4.0 student, they're happy we talked to them, because we're not saying anything bad, right? It's all very scripted. So I do think there's a lot of value there. I think in our specific case, we don't use it. In the persistence question, that's different. So we use scikit-learn for the grade prediction stuff, and we actually use TensorFlow for the persistence. There's a whole story behind that. With that one, the demographics are important, because then there might be something we can do about it. But with the behavior-based and we wanting to alter behaviors, it wasn't as valuable. So maybe not the best answer, but that's the way we do it. There's a few more folks.
You'd mentioned that after 10 days that you're 83% accurate.
Yes.
What's that based off of? Just historical information, or?
As far as the accuracy is concerned?
Yeah.
So yeah, it's exactly that. And so we generate the list, and then in 16 weeks, we go back and we say of those folks who failed. And so 83% of the time, if you're on the list, you fail. Hopefully the interventions help, right? And so that number gets a little worse if we're doing our jobs right. And there's somebody way in the back.
So you talked about retaining customers. Do you also use this approach to target students who might be more inclined to completing the course? New students as opposed to existing base?
So that is definitely a feature that we use, is whether or not you're a new student to college, a new student to Ivy Tech. We have different classifications for that. In our prediction model, there are about 43 features that are most prominent, and that is definitely one of them. And that's really something we've talked about with the next iteration of the interventions, is taking that into account and maybe dividing them a little differently. Again, we knew the lists were accurate. What we do on that list and the actions we take up on it are really where the magic is, right? Generating the list is not the hard part. So that's something that I know that the team is working on, is a different way to prioritize. Maybe it's different interventions if you're a first time in your family college student than if your parents went to college. And that's some of the stuff that the academic folks and the advisors are working through. But I don't know how that's going to turn out, but that's something that they're looking at. Anyone else have any thoughts? Oh, we're giving you a lot of exercise today.
Okay, so you said it wasn't attendance or grades, and you were looking at like different streams of data. What ended up being some of the key indicators that were predicting success or failure?
So there are a lot. As I mentioned, we look at hundreds of features, and then it ends up being 40 or so bubble up to have at least a 0.5% impact, and it goes all the way up. And honestly, off the top of my head, I couldn't tell you all of them. I can tell you that there are some that are pretty insightful. One of them is prior college experience. The one thing with Ivy Tech to keep in mind is that we are an open enrollment school. So we don't necessarily know your high school GPA. We don't necessarily know your SAT score. There's a lot of holes in our data. And so one of the reasons that we went with the machine learning algorithms instead of just more traditional statistical analysis is because we knew there were a lot of holes in the data. And so if the machine can churn through 100 millions of rows quickly and figure out where those correlations are, we're not going to find that very easily any other way. So there are a number of features that matter. I'll tell you an anecdote about one of them. We had started off looking at how many times a student checks their grade. It turns out there is a high correlation between students that check their grades in our environment more than 200 times and them getting an A or a B. We have a few students that will literally check their grade 2,000 times in a 16-week term. Of those, I guarantee you 99.9% of them are getting an A. That doesn't mean the students that never check their grade won't get an A, but the ones that are obsessive about it almost always do well. So that's the weird edge cases that really throw off a lot of the different analysis techniques, which is why we went through the machine learning route. So I really can't answer exactly which ones are most prominent because it also changes a lot based on geography. And this is, I guess, another excellent point. So Ivy Tech as an institution is divvied up around the state. Anybody remember the geography of Indiana? Do you live in Indiana? All right, very good. So we got Indianapolis in the middle, Fort Wayne, Gary's up near Chicago. You've got some folks near Louisville, and then there's other cities too. We are organized as a business with different management in those different geographies. So the folks that manage how Math 1, 2, 3 is taught in Indianapolis are not the same folks that manage how that same course is taught in Fort Wayne, Indiana. Those are different management structures. So for us, knowing that that management structure exists, having geography being a feature is paramount for us. We are not McDonald's. We don't make the burger the same way every place we make one. There's local variances based on a variety of factors. The high schools are certainly one of them. So we have geography is almost always one of our number one features because that geography signifies the different management, the different pedagogy that happens in those areas. Does that make sense? So, and it varies. The number one features from one term don't necessarily make it to the next. And I guess one more point along that lines. If you're in IT, do you guys always know what's going on? Does the business always tell you what they're doing? Do the businesses ever tell you what they're doing? So we have the same issue. If they decide they're going to change the way Math 1, 2, 3 is taught in Evansville, Indiana, we are not on the list to be notified. We don't know at all. So there are business practices that change in these different regions of the state all the time, and there's no way for them to communicate that to us. So having the machine go through there and identify those changes, and from a data perspective is critical to us. There really is no other way we could do it other than using the artificial intelligence things because of those changes are happening constantly, dynamically, and we are the last people to know in many cases. What else? There's one way over there.
You mentioned that this project sort of started off as data gathering to get different streams of data into a centralized source. When you started the actual analytics on that and getting these behavioral indicators, did you have any personal concerns or misgivings or controls that were set up around how this would be used and how you might prevent it from being misused, I guess? Because you also mentioned it got taken up when you got a new president in. For example, did you have any concerns around a president coming in, seeing this data and thinking, excellent, there's all these students that you're predicting with a high degree of accuracy are going to fail, let's stop spending money on them, rather than using it for their benefit?
Yeah, so we've had a lot of conversations around those lines. I mean, certainly security is one of them. How can the data be misused? And there's been a great number of, probably more conversations around that than sometimes of what we're going to do with it. So yeah, that's been brought up a lot. The group that manages what happens with that data is very cognizant of that. It's made up of a variety of different folks, registrar, advisor, several academic people. So there's a committee, if you will, that really decides that. And we're very cautious on what we say. We don't say Bob is going to fail this class. That's not what we say, because if we did, of those 837 voluntold people, someone's going to say that, right? So we're very careful on the words that we use, and we don't really expose that level of detail on the list, if you will. We do have the reasons, right? So if you're on the list of as being predicted to fail, your name is on there, or your identifier, whatever that may be, and then there's a reason why, and sometimes there's 2 and 3 reasons why, depending on your situation. And those are worded in a way that really doesn't give away detail. Ask Bob about the math class. That might be what's actually said. And that language is decided upon by the advising folks, the student folks, and the academic folks. I mean, it's not, the IT guys shouldn't be deciding that. So we're very cautious about that. Up to this point, that's another reason, honestly, why we haven't disclosed it to the students just yet. We don't want it to be looked at as negative. It's informational, but we don't want to discourage either. And so our folks are working through how best to do that. And right now, I don't have good answers on what they're going to do with it next. I can tell you what we've done with it up to this point, and it's been very, very thorough oversight on how that's used, the words that are used. I mean, I can't tell you how many times we've is and the and a and I mean, we've argued over just even the pronouns in this sometimes. So there's been a lot of scrutiny over it. But the academic folks are the ones that drive it. It's certainly not us. Any other thoughts or questions? Oh, there's another one.
So you mentioned a couple of times that there is no scientific model behind the system. I'm guessing you don't have a data science team, otherwise you would have the scientific model there. My question is around what kind of teams you have. Do you have architecture team, data engineering team, DevOps team, some sort of data modeling, data science team? Who came up with all of these ideas? Who did implementation, architecture, integration, testing, all of that?
So, gosh, there's a lot of questions there. So we do have a data science team. It's one person. And he's got probably a fair amount of work on his plate. That's not just this. So we do. When we started the whole project, we had 2.5 individuals that built everything that I talked about. I did all the predictive analysis stuff and the Mathematica stuff. And we had 2 data engineers that architected the picture that I showed you up there. We're a little better now. We have 3 data engineers and a data scientist, and then I'm still a half-time person on it from time to time. So that's sort of how it started. How we came up with it was a bit organic. I wrote most of the code for the initial version, and then we actually hired a data scientist, and he's taken it from that point, and now he owns the iterations on it. We have a peer review process and whatnot as far as going through all the stuff. When we bring in all the data from the different systems, data engineering does that for us. We do a lot of things different there than what most people do, and I'll scare everybody if they're paying attention to this next part. We don't do any transformations on data. We don't cleanse data at all. That is a fundamental thing I think is a flaw, and it's my philosophy, so this is my opinion. We don't cleanse data. That, I think, is a mistake. And so we've proven that it works if you don't. We account for bad data in the analysis. We don't account for bad data on intake. So if you run a report, you're going to see, I guarantee it, you're going to see 5 students that haven't been born yet that are students at Ivy Tech. That is hard, right? But it is in the data. We surface that in the data so that it gets fixed. If we filtered that out before anyone saw it, no one would know to fix it. Then you have exception reporting. Then you have this whole data governance rigmarole that most higher ed folks are opposed to. So we really take a different approach to that. We don't do any transformations. We don't do any data cleansing. We handle that on the output side, not on the input side. From a data analysis perspective with the machine learning, it helps a ton to have that bad data in there. We have found a lot of business problems based on bad data. When we see a feature pop up that doesn't make any sense, we always dive in to understand why is this feature in there. And sometimes it's based on a flaw that maybe the Fort Wayne folks were taught to do X and they should have been taught to do Y from a business process perspective. So we keep the bad data in there, and there's a lot of things that we don't do and that I guess we work around because we don't believe that there's value in it. At the end of the day, we're there to serve students. We're not there to make a pretty IT system. So if we can help by identifying students, the numbers prove that we can do that, and then the academic folks can help them, the numbers prove they can do that, then we've done our job. And that's the way we approach it. Any other questions? Yes. Oh, she's gonna bring in the microphone.
So based on the answers, I assume most of the data that you used to analyze came from LMS system. Do you have a homegrown LMS system or commercial?
So we, from an LMS perspective, we are a Canvas school. We started that in the summer, so around May. Previous to that, we were a Blackboard school. The LMS is a component, but it is nowhere near the only component. LMS is just a small piece of the pie for us. At Ivy Tech, I mentioned we offer 60,000 course sections. Not all of them use an LMS. There's thousands of them that don't use the LMS at all and never log into it. So we have other things included, other features included that accommodate non-LMS classes as opposed to the classes that use the LMS. The other thing with us is we don't necessarily have a adhered to standard on LMS usage. And so we have to take a different approach to accommodate that. Another way to think about it is if you're familiar with the franchise model in restaurant industry, you can have a franchise, you can put the kit out that says, I don't know, Taco Bell or something, but you can do a lot of different business processes and still make those tacos. We're not a lot different with that different org structure. We have different leadership that's deciding different ways to do the same exact goal. Your class may use the LMS, his class may not use it at all. And so we have to accommodate both of those. And that's why our feature set is so large, because we have features that represent behavior based on LMS, and then features that represent student behavior not based on LMS. And so there's a lot of other ways to get it. The nice thing about machine learning is you don't have to be perfect. You just have to have it. Doesn't mean it has to be right. The machine will figure out if it's right. There's somebody, I see another hand. Oh, back there.
So I'm sorry, the cat's out of the bag about why these students are getting called now. Do you think that when you call them, it would be better to just give off the data points that show why they're at risk versus asking a question that may lead to frustration or?
Well, I don't know. To be honest, I'm not sure I can answer that because I honestly have not made the calls. I've sat in the room so I could hear and help as far as making that process more efficient, but I've not personally made any calls. I can tell you that before we made the phone calls, there was a belief within the college, in the leadership of the college, that calling the students was a bad idea. And we had a number of people that were adamant this was a horrible idea. And then with the support of the president, we called them anyway. But one of the things that we captured on those call logs was what was the impression of the student? Were they angry? Were they using foul language? We captured a number of data points on that, and then we reported on that because a lot of people believed this was the absolute truth. It turned out, and I want to say it was 97 or 98% of every student that we called out of the 16,000 were either neutral or happy that we called them. So I don't know that wording it differently would make a difference. That's something that team that I mentioned is working on for the spring. So they're working on some other approaches to help. But the results that we gathered, or the data that we gathered, really proved the approach was pretty good. No one expected, and myself included, to have 98 or 97% neutral or happy that we called them. We honestly was expecting 80 or 70. I've worked at the college for 7 years. I've listened to that same thought for 7 years, and I was accepting it as truth as well. It turned out it wasn't accurate. And the funny thing is about this whole project, I won't say everything, the vast majority of the beliefs of the leadership of the college about how students would react, would this phone call make a difference, almost every single one of them were wrong, and we proved it with data. And so now, as an organization, I think we're much more open-minded about what might work because we've been proven wrong so many times about what we all thought. And in my opinion, again, this is an editorial, there's always some faculty member that talked to some student that had some experience, and that gets blown up to everybody. You guys in higher ed, I heard somebody laugh, so I'm not the only one that's observed that, right? There's always these anecdotes that turn into truth for the whole institution. Now that we have data in a way to track it, we can, if it's true, we'll prove it, and if it's not, then it's not true anymore. And we've gotten a lot better in the last year as an organization of being more open-minded to what might work, because we've seen what does work, and it wasn't what any of us thought would actually work. So to answer your question, I'm not sure what they're going to do with it, maybe, but at least so far, I think we're on a decent track. Oh, there's one there.
I have two questions, actually. The first one is, how did you calculate the accuracy of this model? I still call this model, even though it's not statistical. You said something about the 83%, I guess,
yes.
Right? How did you calculate? That's my first question. The other question is, do you have any intention actually to share this with the other colleges and universities? I mean, this is quite an achievement, perhaps not in the statistical journals, but there are, the rating of the all university is based on a persistency. So that's one of the major, actually, factor. So are you willing to share and how you basically will approach that?
So to the first question on as far as accuracy, we generate the list, and we've done this for, it's been years. We generate the list, and then at the end of the term, when nothing's happened, it's not terribly scientific, mind you, but nothing has happened, we say who actually failed. We started around 68%, 67%. We made some tweaks, got it about to 83%. If you're on the list, 83% of the time, without any intervention, you're going to fail, and it's empirical. And we've done it for 9 or I guess 10 terms now, and it's held true. That's how we calculate it. Now, I'm not going to say that every student that fails is on our list, because there are some that we don't catch. But if you're on the list, we're 83% sure you're not going to pass. So that's how it's calculated. And then to the second question, as far as sharing and whatnot, that's a question I get a lot, and that's something that the college has talked about a lot. I can tell you that I meet with a lot of schools, and we've helped a lot of schools come up with ways to do similar things that we have. And then as an institution, we've also had a lot of conversations about what can we do to help other schools. We have an investment, right? The college has made an investment into this, and we're getting some benefit out of it. How could we get that to other schools in a way that is fair? And that's something that's probably a pay grade above mine, to be honest. But that's a conversation we've had countless times. And as a matter of fact, on Monday, I'm meeting with a college from New Zealand. They're flying into Indianapolis to meet with us on how we did this. And so that's a long flight to talk to me for an hour, but that's what they're doing. So I don't know, we're working through that, definitely. Any other questions?
Your backtest process is to see how many have failed, right? After predicting who might fail.
Mm-hmm.
And then in between then you intervene and you attempt to reduce that failure rate, right?
Mm-hmm.
And then after intervening, you would measure, and then say your measure comes back at 73% next year.
Mm-hmm.
You would attempt to tweak the model to increase your accuracy.
Mm-hmm.
You're catching your intervention in there. And,
Correct.
And
well, the 83% is based on, there's only one term of intervention, the 83%. We've got 10 terms of data where that's been that high.
Gotcha.
Without interventions at all.
Is that a process that you would continue? Because I would worry that you might start selecting for things that cannot be actionable.
So all the features that we feed into the machine learning are all actionable features. That's why they're there. We don't include demographics in that for that exact reason. So there's about whatever there is, 100 and some, 400 and some, depends on who's running it. But we feed in a lot, and it usually boils down to between 20 and 40, depends on the term, that have at least 0.5% or more influence. And that list it fluctuates all the time. So sometimes, and really you can only train it once you have an outcome to train against. And so it's term by term, those things will shuffle themselves. So the idea is that if we have all the behaviors, the right swath of behaviors, it doesn't necessarily matter that some of that other stuff, the interventions are going on, is the behaviors that we worry about. So with the new iteration we're working on for January, by being able to do this every single day, making it part of the entire business process, not just a point in time contact, which is what we've done historically, that should mitigate that. Because if you're on the list, you get contacted, you fall off list, we're not calling you. Your behavior's changed, it's okay. A lot of our features are time dependent. There's a lot of things, I mentioned earlier, we let the data define the cohort. That's a big deal. I can't stress that one enough. That's a really big deal, and then the time factor is also a very, very big deal. So if you don't come to class, and we don't take attendance, but if you're not in class, then all of a sudden you start showing up in class, that's going to show up in the data. And if it shows up in the behaviors that we look at, you're going to drop off the list and won't be contacted anymore. That's the idea going forward. Ask me in 12 months and I'll tell you how well it worked. But that's sort of the direction we're going because of what you've discussed there. We have 5 minutes left.
So this might take a little longer, but I was going to ask, I really appreciated you outlining the architecture of how you're working things out with your data warehouse and these reporting. Can you talk a little bit about some of the other aspects of your overall data strategy? Do you have master data management that you want to put in place? What are some of the other pieces you see will be important to support and continue this endeavor going forward?
So the short answer is no, we don't have a master data management plan. We are very light on some things. We probably should get better on some things. We do need a little bit of data governance, but at the end of the day, really what we try to focus on is what I call the common sense rule. Does it make sense to do this? Is it going to help us? impact the students in a positive way, that's really where we stop measuring it. So, and I've seen this at a lot of schools. I'm not poking fingers. I won't mention names, but I will point fingers at some point. There's a lot of schools that want to build the perfect system, that every single student has their data exactly perfectly right. And I've met with some of those CEOs or CIOs and CDOs, chief data officers, more times than I can count. And they're so hung up on, well, we know this data is not exactly right. And I'm like, okay, and? What's your problem? But they get hung up on the data governance piece. We need a little bit more, I think, to get in a couple areas, especially we need a little bit better control over it. But at the end of the day, we're very outcomes driven. So if I know that I can give the list to the academic folks and out of the, make the numbers round, out of 10,000, 8,000 of those students are going to fail and they can help those students, probably, I mean, that's a win in my book. I think we're hitting the point in some cases of diminishing returns. So yeah, maybe it could be 84% accurate, maybe 85. But we also, unfortunately, have other issues that we could help that are going to be far more impactful. So one that we've discussed but have not, if you're an academic person, have not put into place is doing the same type of analysis on instructors. Because we have a large population of adjunct faculty instructors, we could do the same behavior analysis with them, and I probably have, and I can probably tell you which ones are the good ones and which ones aren't, and I might share that with a few folks. It's not something we've institutionalized or operationalized, but that same behavior analysis works with them too. And so being able to tell that an instructor isn't the best instructor, that maybe, we need to fix this person before they affect negatively, 100 students is far more impactful than spending an inordinate amount of resources to maybe bump it up a percentage point. So we really just try to do the minimum, to be honest. I think there's some areas we could do better. We're not perfect by any stretch of the imagination. But I think there's areas we could do better in, but we just try to do the minimum. If it's the minimum amount necessary to get to the outcome that we want. From the engineer in me, and I'm an engineer, that I want to see it perfect. But at the end of the day, it doesn't matter as much. We make a big leap, we go to another area, we make a big leap, and then we come back eventually maybe and make smaller leaps. But we really do try to do the minimum. So we probably have time for one more question if there is one more. No more?
Can you get this data back to the students before the add drop deadline?
Well, let's see. So I heard two questions. Can we? Yes. Do we right now? No, we don't right now. But there's no reason we can't. Obviously, when we looked at, I mentioned the 2 weeks. So the first 10 days, the quality of predictions is horrible before anything has happened, right? So on day one of the term, there's no point. And there's a curve. We have a probability distribution function that we draw of this, if you're a math guy. So it really starts to be good around 8, and day 8, day 9, day 10 is really when it starts to be good. And of course, the closer you get to the end of the term, the better it gets because there's more data. So we have not done that yet. That's a decision that's, again, not my area of expertise. That's probably a student affairs, academic advising question, not a me question. But today we don't. Anything else? That was a quick one, so we could do one more. All right. Oh, there is one more. Yep. So the question was, can we use something like this to help with enrollment and other things like that? And the answer is definitely yes. And that's where we've gotten with the persistence stuff that I've talked about. We use a different machine learning tools for that. We use TensorFlow, if you're familiar with TensorFlow. And there's reasons that we do it with that tool. But there are some advantages there, and there are other areas of the college that we can use it. And that is. And I guess in some ways, maybe we're victims of our own success and to some degree, because I know what we do is kind of useful and it helps, and not a lot of people can do what we've done for whatever reason. And we are now involved from an IT and data perspective in every possible conversation that happens in the college. If data comes up, there's somebody from one of our team that's invited to it. We're sucked into everything. Not that that's a bad thing, but the good news is everybody at the college now is thinking about data. I mean, everybody. Everybody wants a dashboard. Everybody wants a predictive model. Everybody wants a simulation tool now. And so that's pretty cool because we're using data and being an engineer, I like that. But yeah, we've talked about a lot of different possibilities. I don't know where we're going to go with all of them. Some of them will work well, some of them won't. But yeah, we're definitely involved in all those conversations. All right, we're out of time, so thanks a lot.